I don't think we've built tools that encourage people to reuse, share practices. That is on us, because people by themselves are going to do what's expedient to do their job. They have to have systems in place that encourage them to reuse things and share code and invest in improvement in that. And we haven't. And so I do think there is a very real industry trend where we're standing on top of this very shaky tower and we can't move forward because we have to keep fixing what we have in the past.
This is DevOps Paradox, episode number 234. Better bare metal infrastructure management with RackN. Welcome to DevOps Paradox. This is a podcast about random stuff in which we, Darren and Victor, pretend we know what we're talking about. Most of the time, we mask our ignorance by putting the word DevOps everywhere we can and mix it with random buzzwords like Kubernetes, serverless, CI/CD, team productivity, islands of happiness, and other fancy expressions that make us sound like we know what we're doing. Occasionally, we invite guests who do know something, but we do not do that often since they might make us look incompetent. The truth is out there, and there is no way we are going to find it. P.S. It's Darren reading this text and feeling embarrassed that Victor made me do it. Here are your hosts, Darren Pope and Victor Farsick. Victor, with all the things that have been going on with HashiCorp and OpenTF, everybody's really loving and getting into infrastructure as code, especially when it comes to cloud, aren't they?
Everybody likes a good soap opera to begin with, right? I think that OpenTF, without judging how good or bad it is, I think that's from the user perspective, normal human perspective, it's a soap opera, right? What is going to happen next, right? Who is going to get murdered? I want to know.
It's like a telenovela, or if you're a guy, it's two competing wrestling companies going against each other. That's what it feels like.
Exactly.
On today's show, we have Rob Hirschfeld on from RackN. Rob, how are you doing?
I'm doing great, Darren. Thank you.
Now, you come at it a little bit differently. With RackN, although you probably do some virtualized cloud stuff, you really focus more on bare metal. Like, does that still even really exist?
It's always lurking under the water level. You can't have cloud without bare metal, but most people don't have to deal with it as much anymore. So for our customers, which range everywhere from large enterprise and hyperscale cloud provider down, if you don't do that well, you're not in business, frankly.
So it's similar to serverless, right? There are servers behind serverless. And also there is bare metal behind VMs, right?
Exactly. And we have a lot of interest in people, especially with AI training or large data, who are, trying to get rid of the virtualization layer. It's either expensive or it adds an overhead that people don't want. So there's a lot of places where if you can do bare metal well enough, then you start questioning whether you need to do virtualization.
That seems like heresy.
There's a lot of virtualization that's beneficial, and we definitely don't discourage people from using it. It's just everything has a consequence.
Here's a question. I understand how virtualization is very beneficial, or was in the past, right? Because it provides isolation, it provides this or that, right? But now many of us are using Kubernetes, meaning, hey, I have 5,000 virtual machine nodes, and they're all treated as one big server almost, right? Now, why wouldn't I run that on bare metal?
Oh, I love that. You might want to. There's a couple of reasons why bare metal Kubernetes is not as widely adopted as you might think it would be. One of them is just the size of the machines. Kubernetes consumes resources at a certain rate. And when people buy servers, they typically buy a lot more RAM or a lot more disk or a lot more network. And so if you're running a cluster, having a whole bunch of small hosts in that cluster is perfectly reasonable to do. And so instead of buying a whole bunch of small bare metal machines, which creates its own management challenge, taking bigger bare metal machines, partitioning them into smaller machines, and then running the cluster in that makes a ton of sense, right? So there is a logical thing. What we attack is wait, if I could make bare metal more manageable, then that would become a more attractive option. The other side of that coin is, doing things like installing operating systems, managing lifecycle, making sure RAID and BIOS is patched, setting up networking, right? When you start talking about bare metal, there's a lot of operational characteristics that you need to get right and can be difficult to automate. You don't, that not all of those instances and systems have the APIs that you want. Building workflows across all those APIs is complex. It's what we do. We spend a lot of time dealing with all the vendors and the networking and the storage configurations and the operating system variants. That requires, a fair bit of expertise. For most people operating Kubernetes today, the fact that I can go to a cloud or a VM, say run this OS that's pre-set up to run Kubernetes as Kubernetes hosts and only attached to NIC number 1, that drives out so much complexity that it's really, really valuable to be able to do it that way.
That was just as much or even more referring to vendors, right? In theory, and correct me if I'm wrong, because this is really not my area, that same vendor could give you the same service with unified same operating systems based on bare metal, right? You wouldn't necessarily even notice, right? Assuming that you run at a certain scale, right? So I'm talking about, I have 100 nodes, 1,000 nodes.
This is something we see in the bare metal as a service business. What ends up happening is if you're a bare metal service provider and you want cheap servers, you end up buying cheap servers, and cheap servers are cheap servers. And they have a lot more operational challenges in them than if you bought a more premium server and then managed its lifecycle and things like that. So it's one of the things that Google would do. They were famous for this model, and it was a really powerful thing, is they would buy racks of inexpensive servers at Google scale. And then when machines would die, they would just leave them in place and keep moving until there was a sufficient death rate on the servers that they would replace a whole rack. But to do that, you have to be able to operate at a degree of scale. So what we find is most customers still buy relatively expensive servers, add virtualization on top of them, and then let the virtualization manager deal with a lot of the things that we're talking about as complexity adds. What we do find is that as our customers get more and more used to having bare metal that is API driven and really dynamic and easy to turn over, they ask, wait a second, maybe I don't need to pay the overhead for doing that. But we don't see them necessarily turn around and say, I'm going to now buy quarter-size servers. That's a whole nother step forward. And just for the record, it is more than a quarter. I want to do the math in the simplest possible way. Big servers are more expensive than the same amount of commodities divided by that number. So when you buy big, expensive servers, they are actually more expensive than if you took the same amount of, say, RAM and network capacity and bought smaller servers with it, because the smaller servers don't have as much deluxe redundancy and controls and things like that. So you can actually save money by buying 4 times as many servers if you needed the same number of CPUs and RAM. The math is very fascinating here.
It seems like, though, I would still want to buy the one big one. Actually, I'd buy multiple big ones. So if I was going to buy 4 servers, let's say I needed, and I sliced them down and it ended up being 16 smalls, and I saved $10,000 or whatever the math is.
You wouldn't. You'd actually
Exactly.
you'd actually spend much more for the 16. You'd actually spend more for the one server than the 16, because to get a server that can run that much RAM or that much networking, right? You start saying, oh, I need a fiber channel card, and I need 50 gigabit networking, and I need, right? So what happens is that when you decompress things into smaller units, you can get by with 16 machines with gigabit networking. And that actually has a huge savings in cost. You might not need as fast RAM because you're not trying to address as many RAMs. I don't need a quad socket motherboard. I can get 16 one socket motherboards. All of the costs associated to that drop dramatically when you decompose things into these smaller units. And there's this interesting economics on the other side of it. Those savings for most people are overwhelmed by the idea that now I have 16 things to manage, that I have to do out-of-band management and RAID and BIOS configuration, and I have to worry about which NICs it is, and I have to have a supplier for it. Those issues, which RackN, we work to make non-issues, but for most people, they look at that and they're like, wait a second, I'd rather deal with one big expensive thing because my management cost on that unit is the same as it would be if I had 16 of them. So the fundamental question, and this is actually an infrastructure as code question at the end of the day, the fundamental question is, can you significantly change the management overhead cost per server in a way that makes the 16 machines more cost effective than the one? And if you start thinking about what we could do with ARM infrastructure, you could have 100 servers, but most companies look at 100 to 1 increase in server numbers, and their admins go insane because they're already struggling on the ones they have.
You stole my question or comment almost. I was about to ask, how often do people actually remember to include humans in those calculations?
Oh, sadly, they don't as much as they need to, because I think a lot of times when they go building things, they don't think about the cost of maintaining the systems that they have. And that's part of it, or how much time it takes to do it. I've never met an ops team that felt like they had enough time and enough people to do the work that they're going to do. So in a lot of cases, I think the rush to cloud has been an acknowledgement that the ops teams didn't have the time to get things done. And instead of asking to do it, they just get bypassed. But yeah, the human component in this and the time it takes to do it is very, very real. And the consequences of not having people able to do that work. For some of our customers, like financial services customers, that translates into fines and penalties because, servers that don't get patched, they end up having to insure, or they end up with security breaches, or they end up with just a not passing audit.
So if we're looking at servers, you initially said cheap servers and premium servers. I am not in the market today buying servers. I used to buy servers all the time. Probably 20 years ago. That was a very normal thing. Just show up one day. Here's the weekly shipment of, what was I buying at that point? Probably Compaq and Dell. I'm that old. What is cheap today? Because when I hear cheap, I'm thinking, okay, Raspberry Pis. I'm going to stack it up with the Raspberry. Okay, not that kind of cheap.
It really depends on what you're looking to do. That we see edge-enabled infrastructure, which people would consider a very lightweight server, in the $500 to $1,000 range. And this is one of our challenges from a management price. It's not cheaper to manage a $500 server or a $1,000 server. In some cases, actually more expensive because they don't have all the out-of-band management capabilities and things like that. So if you want, Intel stopped making them, but the NUC, right, was about an $800, $1,000 unit. Maybe you put some more commodities into it and you're going to bump the price up to $2,000. It's like a nice desktop. There's some really nice embedded servers that all the OEMs are making that have like cellular antennas built in as a back pane and no fan cooling and things like that. That'll sometimes get the price into like $3,000. But that's about what we're talking about on the low end. If I was looking at data center class equipment for that, you're probably looking at about a $10,000. I think there's I've seen some customers who go like super micro, really cheap base systems, but that's not usually what people are looking at. Because in the data center, you start wanting some degree of dual NIC or redundancy in the control planes and pieces like that. So those would be about the low ends that I would expect to see. And the high ends go crazy. If you can even get all the commodities you need to build a server, we have customers who are looking at a high-end system, not even custom built, but like with 10 GPUs in them, fiber channel machines, fiber channel NICs to handle the offload. You start looking at that stuff, and those are probably at least $200,000 or $300,000 individual boxes.
Where do these companies come up with this money to buy this kind of hardware? That's amazing to me.
Wait. They
get a lot of value out of them.
I have the answer to that one. If it's buying right now, you just need to say AI. And you get money from investors immediately.
The ROI on a server like that is, 7 months, especially from a hosting company.
Wow.
That's assuming they can even find the commodities for it, right? Especially the NVIDIA GPUs, very tight supply.
Now, the other thing you were talking about is working with vendors to make sure they had APIs on the hardware. Now, coming from a background doing networking, it was always easy to do that with the Ciscos or any of the other variants. But APIs for compute, I mean, at best we had, and I'm going to pull a Victor here, CF Engine was his first, if I remember correctly. I came in before chef and puppet. So I was sort of in that wedge. What is, I'm not even going to say state of the art, because I have a feeling what you're going to say is it's not much more than bash scripts today still.
What we do from a product perspective for RackN is way, way beyond what a bash script would be. But there's still a lot of bash scripts in the middle of all those pieces. It used to be, and there's still a lot of this technology out there, a protocol called IPMI, which was IP Management Interface. It was basically able to talk to the computer interface, what they call a baseboard management controller, or a BMC, to sort of turn the servers on or off or patch their BIOS. That protocol is still pretty available, but it's been happily replaced by something called Redfish, which is a new standard. Still would, for most people doing web work, would feel pretty old school. The challenge is that even though Redfish itself sort of is standardized, it is still highly variant vendor by vendor. And so the problem here isn't actually that there aren't ways to interface things. The challenge is that the variation between the different protocols is very high. And then the sequence of operations is very, very specific. So when you're actually doing this type of automation work, and the reason why we ended up with a lot of bash scripts for it, not even Ansible for it, is that you have to have a very specific interaction sequence to get systems to work at the right time. You have to wait for systems to settle. Sometimes they have to reboot 2 or 3 times to accept a patch change. And then you have this very tricky control model where sometimes you're working inside of the system, on the system when it's running, and sometimes you have to work outside of the control plane of that system and talk to it on that out-of-band management interface. And it gets even more complex because to bring up a system, you also then have to talk to DNS infrastructure, you have to talk to DHCP, you have to make files available in different locations, you might have to talk to an Active Directory and register a server. And this is what people forget about bare metal. It's not just, can I talk to a server? You actually have to be aware of all of the systems that server has to interact with to come online. And so that's where the complexity comes into what those are. We use a ton of bash behind the scenes because that's how you interact with all these tools. And sometimes you don't have a choice but to be like, all right, I have to make a call to this thing, and it's a script. I don't shy away from a bit of bash when necessary. It makes the world go round.
That means that when a new model or a customer gets a server that you did not work with already, kind of, that sounds like a horrible scenario, kind of like, okay, a new model was released.
One of the things we've been really good about avoiding is this combinatorial explosion of servers and operating systems. We're having more trouble right now with the changes that the vendors have been making in operating system formats and layouts through their generational changes in the vendors. The hardware OEMs are remarkably good, and hats off to them, at making their tools work generation to generation to generation. There are changes, and every time a new generation comes out, we have to requalify what those are, but that usually ends up being what we would call a quirk. Then it is a rewrite. But I mean, at the same time, the differences between like a Cisco system, which has its own specialized APIs that have to be talked through Python, versus like what a Supermicro does, which doesn't have that much consistency, versus like Dell is super consistent in their tool chains. You have to be able to absorb those variations. But you get crushed on things like NICs enumerate differently depending on the model, the gear. If somebody puts a new NIC, we had this happen the other day. A customer bought the same model's gear, but they added new NICs into them. And those NICs cause the enumeration to change on those servers when same server, different NIC enumeration, and their networking doesn't come up the same way. So they have to account for that. That's the way it is. You change something and it gets wonky. A lot of the next generation Linux kernels and the way the file systems get lays out doesn't match the way 2 generations were. And we're building software to accommodate the fact that the Discovery OS no longer knows how to talk to those file systems. You just got to do it. It sounds horrible, but you got to do it.
So support people working on in a company like that need extra payment for a psychologist or something like that.
It definitely adds in a degree of complexity. The fun thing for us, because of infrastructure as code, we do this work once and then propagate it. So our like single mission with all this is like, every time we've been in operations environments in the past, each operations environment, every customer, every company has had to figure out the same problems over and over and over again. And with infrastructure as code, we're finally able to deliver automation so that everybody can use the same work. Because that's what drives me nuts. It's like when you're talking to your buddy and they're doing the same, they're like, oh yeah, I had to solve that same problem. And you're like, well, hand me the scripts that did it. And you look at the script and you're like, I can't use any of this because I'm using HP and you're using Dell. They had solved the same problem, but you got to figure the whole thing out again. That is, I mean, that's what ops has been. And it's really not acceptable. That sends people to the bar.
Is there some kind of uniformity from the end user perspective? So for example, if I use some kind of infrastructure as code and to create and manage, let's say, I'm going to simplify it, VMs, EC2s in AWS. If I go to Azure, I can just throw it to trash and start over. Now, it doesn't matter which tool I'm using, right?
Yeah.
Is it similar with bare metal?
It is similar in that, yeah, we were talking about Terraform and the fork and things like that before. Terraform is brilliant and horrible at the same time here in the same way, right? You can use Terraform against any cloud, and your actual work in Terraform isn't portable to any cloud. So, yay, I can use the same tool, but none of the lessons learned, none of my automation, none of what I built actually is portable at all. And so in a lot of ways, bare metal is in some ways better. At least Linux is consistent across the machines, right? The kernel is consistent in a lot of ways. The pieces and parts are the same. So there's a lot more reusability in that I've gotten a whole bunch of pieces and parts. A lot of times the variation that we hit is self-inflicted variation. I used to joke, every customer interaction, we'd build a certain amount of trust with them, and then they'd pull us aside and apologize for all the operations choices that they made to be able to make things work in their data center. Universally, like every operator will apologize to you for what they've built. And they actually have pretty much done all the same things because the tools force them down all the same paths. And so there's sort of this funny thing where everybody's doing the same stuff, but nobody realizes that they're actually doing the same things because they haven't had a way to share it, or they feel like they're doing it wrong and they don't want to share it.
We were talking about generational things of hardware.
Yeah.
What about the generational things of humans? I mean, you've been in this game long enough now, and you were just talking about people pulling you to the side and saying, hey, I'm sorry. It seems like there's like a bigger story underneath that, yeah, we've been doing this for years, but we're still not getting it right. That's what it feels like.
It actually feels like, and this is true even with cloud. I've been watching the industry, and I love like sort of this Don Quixote tilting at windmills idea here. But we're constantly running around saying, I need to automate, I need to automate, I need to automate. And if you actually sit somebody down and ask them how it's going, they're going to say, well, it's so complex. My automation is really fragile. We have a lot of automation. I don't even know where most of it is. They keep doing this work, and then the horizon keeps getting further in front of them for that work. And I think this is a very real concern. We had a roundtable with some financial services people a couple of weeks ago, and it was stunning because he said, one of the panelists said, it's not that we don't have enough automation. We actually have more automation than we can maintain at the moment. And so you do get this challenge of not, and I actually blame the tools here to a large extent. I don't think we've built tools that encourage people to reuse, share practices. That is on us, because people by themselves are going to do what's expedient to do their job. They have to have systems in place that encourage them to reuse things and share code and invest in improvement in that. And we haven't. And so I do think there is a very real industry trend where we're standing on top of this very shaky tower, and we can't move forward because we have to keep fixing what we have in the past.
I mean, we move forward when you get a new tower.
We leave jobs and we go to a new tower and we look at, and this we see all the time. You switch jobs, you're like, oh, the past people were so stupid. I'm just going to go and build a fresh tower over here. And you still end up having to maintain all the old towers. They're still lurking in the background. You're going to have to fix them.
That sounds very much like my mom. Every second time I talk with her, she tells me how the new diet that she's doing on right now, that's the one. The 5,000 diets that she tried before, that's forgotten. Doesn't exist, right? But this one, that's the one.
That's it. And then there's a archaeological dig of supplements and nutrition aids that go with each diet that are now somewhere in the pantry.
Exactly.
Yeah. It's always, that's what we see going in with a lot of these systems is you do have to, and we try to do this with respect. You don't want to walk in and say, here's a new island that we're building or a new tower. You actually want to come back and say, all right, how do we fit what you have into your operational practices? Usually people have made pretty good decisions, but we have this temptation of burning down the bridges. There's actually a Kubernetes story in here. If you'll indulge me a story, and this is very cloud native sort of thinking that I don't think is as productive. Like I was in a hallway track meeting with a whole bunch of cloud native people, and I was talking about some of the architectural patterns and legacy apps and migration strategies. And one of them turned to me in all seriousness and said, yeah, we're just burning all that stuff down. Switch it to Kubernetes and run it there or get out of town. I'm not interested. And that works for a certain degree of people in building new applications and things like that. It's not my preference in how to work with people on this, right? Most companies that we're dealing with have well-established value-generating application stacks. And migrating to Kubernetes, it might not even be the right answer. It might be a great thing to do, but it's going to take them a lot of time and it's a lateral move for most of them. They have to have a benefit to doing it.
I feel that that's where many startups, at least those I speak with, completely fail. After a couple of years of building something, they go to a first bigger prospect, right? And they're faced with reality that existed before they entered through that door, right? It's kind of, I feel that a lot of us in vendor space are falling into that trap, right? Of course, you want to present something new, you want to sell something that is better than whatever people have, but then you fail miserably simply for not understanding that the world existed before that.
Yeah. And that's super hard because you don't want the legacy, you don't want the baggage, and you need to be able to position a really big value. And we're helping somebody improve a legacy system is usually an incremental win. But I do feel that we are reaching a point, to the earlier question about where things are going. We're looking at this N+1 problem, right? And seeing it as complexity and trying to figure out, all right, a customer was telling us this before. They're like, all right, if we're bringing in your system, we need to shut down 3 other systems. And I think that's the right attitude, but the work to do it, right, there's political capital, there's human capital, there's time and effort, there's testing. You have to be willing to make the investment to do that. And that means your ROI has to be really big. Or you have to be migrating from human cost of maintaining those 3 other systems, which I think is real. Now we're back to including the human cost. A lot of times those 3 other systems have significant, teams supporting them or code bases that have to be maintained and things like that. And you have to account for those costs when you look at, you have to be very intentional in that migration.
What you just said, we need to shut down 3 systems. That sounds so refreshing and unbelievable at the same time. My experience is, yes, we have mainframe, which is wrapped in C, which is wrapped in a layer of Java, and we just finished wrapping it in Go, and we now understand that Rust is the solution to everything, and then we wrap it into Rust, right? Or, hey, we switched to Terraform. How can we run Ansible scripts from Terraform, right? Because we are not going to remove anything, right?
Oh, it's that the flavor of today is really hard. this is one of the biggest things that's been an eye-opener for me as we help companies sort of integrate all these pieces together, is getting out of there are no right choices, there are no wrong choices. There's things that you've done in the past and we're going to have to live with.
So, there are wrong choices. There are wrong choices.
So there are definitely wrong choices. What I would argue is that once you've made a choice and put something together, you're not accomplishing that much to turn around and say that that's the wrong thing to do. From an ops perspective, you're going to be supporting it. And you can actually do a lot of harm. And I've seen this for people who are just keep turning the wheel. This guy liked Dell server, so we bought Dell for 2 years. And this person has a relationship, a golf buddy who's, HP salesperson, and we're going to switch to HP for the next whatever. That type of churn is really destructive. Same thing is true with reorgs. We love to reorg, and organizations love to reorg, and it creates churn. Marginal benefit in a lot of cases.
So we're talking about flavors of the day. I have a bad feeling that AI is going to fall into this.
Wait, first, the important question. Is your solution already fully AI compliant sticker? Are you using AI? Do you have an AI running in your office and managing all your customers?
The ChatGPT is telling me how to answer this question. Hold on a second. Oh, goodness. I don't think AI is a flash in the pan. I think this is real. But there's some huge buts in this. I don't think the current generation is going to help us. I think we're going to find that it's too easy without any guardrails at the moment, and there's going to be consequences on this generation. RackN did actually, we spun this up, and our journey is useful because we have an intern, a graduate student doing AI work for us. And our first pass through this was to say, hey, can you help generate automation for us? And your infrastructure is code. Can you build it? And I've done some I'm doing actually more and more talking about how to use AI to do DevOps work and code generation and things like that. And the interesting thing is the output of that is actually functionally correct and horrible to use. It will generate correct Ansible or Terraform or Digital Rebar scripting, but it has no knowledge of what you should do in the context of the right thing. So it doesn't know your operating environment. It doesn't know if you already have an Ansible script that does that or a Terraform plan. It doesn't know if it meets your governance or not. So you're literally building stuff that's fast and easy, but is actually adding technical debt to your organization from day one. What we recognized is that having our customers generate automation in Digital Rebar faster was really destructive if we already had comparable automation, right? We're all about code reuse. So for us, if somebody's writing something that we already have in the library, that is significant degradation of service. So what we did instead was we got far enough along that path, we recognized it was going to cause harm if people used it. And we pulled back and said, we're going to have a chatbot that helps people find the existing automation and gives people clues and hints about the right way to do things. That's actually what we're building into the product, is actually something that'll help add to the expertise of a user. And in that case, I think it's really, really significant. If you've played with ChatGPT or something like that and said, hey, I want you to help me design something, and it walks through a series of questions, it will be a very good mentor or design assistant for you.
I'm on the verge of being addicted to ChatGPT and a few others. So, and I have zero doubt that will play, the role it will play will only increase with time, right? I was more referring to everybody is trying to make a quick buck out of it, right? Put the AI sticker.
We're a company that specializes in physical infrastructure automation. We have the concepts quick buck don't usually come up for us. We're the long play in how things go. But yeah, there's no adding the idea of sprinkling some AI into stuff is, I think, going to result in some suboptimal solutions at the moment. We still don't know.
Since you're working bare metal, how many of your clients have you had that were cloud and decided to come back home to bare metal?
all of our customers are successful, effective cloud users. As a matter of fact, it's one of our success criteria of our best customers are the ones who most people think of as amazing 100% cloud people. And they are taking that skill set and realizing there's repatriation, there's ROI for having bare metal. There's things that you can only do in bare metal, like our media rendering farms is a good example. There's data governance and protection. Like we work with some of the adult gaming, meaning gambling, where they have to have a presence in every state that they're going to offer gambling. And then so they have to actually have, there's locality issues, right? So there's a lot of reasons why companies would need to have a better story on managing their own infrastructure. And that's really how we see it. It's not really about the bare metal. It's about control of your own infrastructure. And if you're going to do that, you better have the bare metal up. But there's a lot of reasons why the ROI for owning your own infrastructure, having your own control is real. And so we see that.
I feel that one of the big things or important things with cloud, apart from the obvious, you can get whatever you want, whenever you want, is that it changes the expectations from companies. Once you run something in AWS, and let's say it's a hybrid, right? AWS and on-prem, and then you go back to your on-prem with completely different expectations, right? Okay, so it's not okay anymore to do what we've been doing for 20 years. And now I understand what the expectations are in a way.
What we find is that the customers for us who want to do that work, they come back and say, I need API-driven infrastructure. I need highly reliable responses when those APIs hit. I want to hook things into my CI/CD system, right? I want to be able, we have customers who rebuild whole racks at a time. And if you can do that in 15 minutes, then they can do that on a weekly basis. It becomes normal. And those are cloud behaviors. That's the thing right? All of that stuff comes out of these teams that are used to doing the work in the cloud and have high turnover rates and very elastic infrastructure, and everything's triggered by CI/CD pipelines and orchestration and things like that, right? We don't build systems that are designed to be used by operators doing point and click work. We build things that are designed to be integrated to other systems and not operated by humans at all. That's the goal. And so those customers are the ones who are doing cloud.
What is the oldest piece of hardware that you've had to automate?
Oh my goodness. We actually have done some automation in some IBM mainframes where customers needed us to manage that. The oldest I don't even know. We have a new guy who just pulled out a whole bunch of Dell, I think 5.0 something series. They're probably 10 years old in that. And we definitely have gear dating back from when we've been doing this work in one form or another for 13 years. And I still have servers that we put through the automation cycles from those days, some ancient Supermicros. The weirdest we've had is just Raspberry Pis. We were doing early Raspberry Pi bootstrap provisioning, and those are pretty limited. But it's been remarkable, the breadth of stuff we put through the provisioning cycle. And what doesn't work is always surprising to me. It's weird.
What do you mean by that?
So Pixie booting, which is what the sort of the baseline, how things work. And that's an ancient protocol. It is almost relies on tricks of how things work. It relies on certain types of packets and network forwarding techniques and a chain of operations, right? When a system boots, especially if it's using the older Pixie technologies, it goes through 6-staged reboots as it boots from. It's a bootstrapping process. So, right, so people, I'll be explicit. In the oldest school, if you go all the way back in time, the Pixie boot system gets a very simple OS image. It's built into the network cards. And then that downloads a bootstrap kernel using TFTP, which is a FTP. It's a lightweight FTP protocol. And then that in turn brings up an OS that can load via HTTPS, and then that loads an OS that can bring in through HTTP, then HTTPS. That'll bring in actually a reasonable bootstrap kernel that can then bootstrap further. By the time you get through that stack, you've actually gone through usually 5 or 6 kernels. Depending on your DHCP, you might have gotten 5 or 6 different IP addresses issued to you because each one's a new boot. So what happens is that process relies on a degree of magic that is very fragile at times. And so we will see BIOSes that will not send the right characterization information back. We'll see switches that eat packets or don't forward packets. We see network and BIOS pieces that just don't actually respond the way they're supposed to respond. That happens to us all the time, especially with new hardware. The work on ARM doesn't do anything that's normal at all. The Pis, the reason why those were so hard is that they didn't have PXE built into them at all. So somebody hacked it into the graphics driver. And so you would load a PXE booter that would run when the graphics card started, and then it would simulate PXE, but it had to have its own special packet format. And so we had to hack in packet formats for this. We end up with all sorts of little exceptions and special rules to handle all sorts of different things. Switches have their own weird protocols on how they boot and download new firmware images. So it's a pretty bespoke world in a lot of ways.
Have you ever had to create an appliance, air quoting an appliance right now, to be able to interact with another piece of hardware that you had to manage?
No.
That sounds like a good thing. Okay.
No, we did. There's a really interesting technology in what we do at Digital Rebar where we make it so that you can run containers on our platform to handle specialized environments. And one of the things that lets us do is that we can take a server that doesn't have an interface that we can use, and we can then talk through whatever tooling we need to an out or bound interface or to that machine. It's really handy for appliances. It's how we originally started doing it. Like you take an appliance that's made out of commodity servers. Our customers want us to treat those as commodity servers. So normal bring up, RAID, BIOS, configuration, discovery, all that standard process. Then you install the appliance OS on it, and the appliance OS says, you're not putting an agent on our system. You can't even log into our system. It's a locked box. Here's the API. And so what we're able to do is put that vendor's tools into a container, and then the workflow that was running on the machine actually transitions to an agent running in that container. And then we can keep talking to the box through the vendor's tools in the container and transition back and forth. We call that a context. And we're switching from in the machine's context to an out-of-band context or a API-based context. It's been incredibly important, but that need is pretty common because very few people, hardware vendors, build tools thinking about the operational work that goes into making that server finish the whole process. And so we're always finding ways that we have to sort of chain together bits and pieces to make things work.
How often people take that into account when purchasing hardware? I mean, do they say, hey, I'm going to purchase A instead of B because A, it's a bit more expensive or cheaper, whatever the reason is, but also it has the operational capabilities that I need?
Customers will get one vendor and then build a tool chain around what that vendor is able to do. And they get stuck with that vendor because they end up customizing to that tool chain. So that happens all the time. And we talk to companies that are like, yeah, we're a Dell shop. We want to switch to HPs, or we're worried about the supply chain running through China, and we want to switch to, I think Cisco has a more stable US-based supply chain, right? And so, not that I'm advocating one vendor over another. These are what customers say, but they're like, if I do that, my admins don't know what to do. My tool chain doesn't know what to do. I don't know how to qualify the gear, right? They have layers of problems built into that. And they typically didn't ask that question before they started down the path. And you would think they would come to us and that would be like, we would be selling RackN like hotcakes just on that one feature. We're back to where we started, which is the cost of managing that server sort of baked in. And there's other more important capabilities for people than the supply chain independence. As much as they should be asking that question from the start, usually I like to describe it this way. Even if you buy new servers, you're moving into a brownfield data center. So there's really very few true greenfields, meaning never, you get to make all the design decisions you want. And so most companies in every circumstance have got to deal with whatever their legacy decisions are. And then they forget that those were decisions that they made. So, but it definitely is a anchor around a lot of operational environments.
You've mentioned the phrase digital rebar a few times.
Yeah.
What is that?
Digital rebar is our product. We love the name digital rebar. It's this idea of the hidden layer of interconnectedness that makes the foundations of building strong. So inside rebar itself is metal that you embed in concrete to make it durable. Digital rebar is our product, and it literally connects all of the infrastructure together in a day 2 management cycle. And so what we're doing with this is we're actually taking the bare metal of data centers and then connecting it together so that you have strong, robust infrastructures, code-driven models to manage it, an API. And then it's not just having an API for servers that's more functional, it's actually having the way to control exactly which automation is used in that environment, right? And then share and reuse that automation. So when we show up at a customer, Digital Rebar is a platform that they're going to install. It's not a SaaS. And then bring in version controlled automation that can take this infrastructure they have through predictable life cycles driven by APIs. And then when we fix or improve that automation, they can take advantage of what we've done as part of those infrastructure pipelines.
Who is a good client for RackN? It sounds like it's not going to be, mom and pop restaurant down the street.
We definitely do focus. It's somebody doing direct work. Our direct customers are much more Fortune 1000 and government, companies that are running multi-site, big bare metal infrastructure. We have customers that are 20, 30, 40,000 machines managed by Digital Rebar with global footprints. So definitely those types of accounts where that's very high need to have the quality infrastructure. But we also have customers who are running 10, 20 servers who are looking, they just want better API controls and they want to automate things. So the beauty of having standardized this automation is that, even if you don't have thousands of servers, the idea that you're going to begin with pipelines that already do the work, that already know what all the Linux types, already know how to install Windows, how to bring up VMware or other operating systems. Having all that out of the box means that if you don't have a lot of admin bandwidth, and nobody does, but even a small company with one person doing all that work is going to get benefit because they don't have the time to reinvent the wheel over and over again.
Last question.
Sure.
Where did the name RackN come from?
RackN is very simple. This idea of being able to have an unbounded amount of infrastructure available to you. So, we really see it's rack to the nth power, although rack nth sounds a little bit hard to do. And we used to actually supercase the N in the RackN name. But this unlimited rack potential of having unbounded infrastructure is the core of what we're trying to do.
So RackN is at RackN, just like how I'm saying it, RackN.com. Rob, thanks for being with us today.
My pleasure. Amazing questions. We definitely went down some interesting areas of infrastructure, and I hope it was interesting for y'all.
We hope this episode was helpful to you. If you want to discuss it or ask a question, please reach out to us. Our contact information and a link to the Slack workspace are at devopsparadox.com/contact. If you subscribe through Apple Podcast, be sure to leave us a review there. That helps other people discover this podcast. Go sign up right now at devopsparadox.com to receive an email whenever we drop the latest episode. Thank you for listening to DevOps Paradox.